Okay, so we need to carry on with quality of tests today. We have to skip out exercise 8b and sort of that section because it's talking about quality of tests with normal distribution, and you haven't covered normal distribution. There's quite a bit on normal distribution in further stats 1 and 2. So that's something we'll do quite early in year 13 next year. And then when we've done that, there's quite a lot of extra stats that we can crack on with. In the textbook, there's this example that's about the normal distribution, and then it goes on with this explanation. I think this is sort of really important thing for you to look at and for you to understand about how a type 1 error and a type 2 error are really, really closely linked. And trying to reduce one will make the other one increase. So it talks about here an example of a balloon. If you want to make one side smaller, you push it down and the other side goes up. And so generally, it's not possible to decrease one without the other increasing, and the way around that is to increase our sample size of the things we're looking at, and that will generally allow us to bring down the probability of either of them happening. A bit like when you're sort of doing experiments, rolling a dice and doing a lot more experiments, that sort of brings down or brings things close to what you would expect. So what we're going to look at today is calculating the size and power of a test, and these are sort of two quite specific things that we'll look at how we calculate them today, and then on Monday we'll have a look at how we sort of apply them and why those things are useful. So the size of a test is purely just our type 1 error. Remember, our type 1 error is our actual significance level. So you work out the critical region and then work out the probability of it being within the critical region. Now, the power of our test is 1 minus the probability of a type 2 error. And this is really, really useful and something that we'll look at. Power is something we'll look at a lot later. We'll look at something called power functions of a hypothesis test. The reason why we can do this is because if we think about if the hypothesis is true or not, those H1s are going to have to add up to 0, which is why we can do 1 minus the probability of a type 2 error. One thing that we will be looking at when we go into these next examples is that to be able to calculate a type 2 error, you need to know what the actual underlying variable is, and in all cases you wouldn't be doing a hypothesis test if you knew what the underlying variable is. So next few examples we look at are sort of more just like contrived questions for you to be able to work through in an exam. In sort of real life you wouldn't have that information, so then on Monday we'll have a look at what we in real life situations what we actually do and work out a way around this. Okay, so we're going to look at an example here. We've got a binomial distribution, we've got a sample size of 25, got a hypothesis or null hypothesis that p equals 0.3. Alternative hypothesis is that it's less than 0.3. So straight away it's telling me it's a 1-to-hour test. We've got 10% significance level. We want to find the critical region. So we're looking for the first value that gives us a probability of less than 10%. So we write it out formally, use our table, use your calculator, however you want to be doing this, and we get the critical region is x is less than or equal to 4. We can find out what the actual significance level is. So we've got here that it's 9.05%. So that's our actual significance level in terms of rather than just a significance level that we're given in the question. So our type 1 error is going to be our actual significance level, which is also the size of our test. So we're here just 9.05%, so nothing particularly new there. Now, part C, we have to be given what the actual probability is of like the distribution. So we're given that it's 0.2, and then we're going to calculate the power of the test. Now, if we look back at the last slide, we talked about the power of the test being 1 minus a type 2 error. However, we could just calculate this box here. Okay, so either we can do 1 minus a type 2 error, or we can calculate this box here. So in this situation here, we're just going to calculate the probability of accepting H1. So we're going to do P is probably that we're in our critical region, so it's less than or equal to 4, given that we're probability is 0.2. So it's just doing exactly the same as we did up here, doing binomial distribution, where we've got our p is 0.2 and we want less than or equal to 4. And then we get this probability here of 42%. And that's all we need to do for this example. So there's a couple more examples in the textbook if you want to have a read through them. There's one on normal distribution which you'll need to skip over, and then there's one on the geometric distribution for you to have a look at. If you then go and work through exercise 8C, just work through all of the questions but leaving the ones that are normal distribution questions. I think that's just question 1 and question 10. We'll carry on with this chapter on Monday, and we'll finish this chapter on Monday, and then we'll do a little bit more pure, and we'll go on to back to having a little bit of a look at some of the work on complex numbers. What I'd like to do next Wednesday is have a go at doing another Zoom tutorial, and I'll post some more information about that on Show My Homework for you to have a look at. But hopefully this all goes okay and this makes sense with what we've done in today's lesson.